Hi, welcome back to LeetCode. So in this video, I'm going to discuss LeetCode problem 3599 partition array to minimize XOR. So you are given an integer array nums and integer k. Your task is to partition nums into k non-empty subarrays. For each subarray, compute the bitwise XOR of all its elements. Okay. And return the minimum possible value of the maximum XOR among these k subarrays. That means for this example 1, our input string is 1, 2, 3 and k is equal to 2. So that means we have to divide the input array into two subarrays. So how actually I can divide? I can one divide actually here. Okay. So then one subarray will be 1, another will be 2, 3. One more actually divide actually I can do in this position. Then in the first subarray it will 1, 2, 2 will be present. In the second subarray 3 will be present. Okay. Any other way is it possible to generate two subarrays? No possible, right? Not possible. So for this subarray, for this combination, so what is the XOR for this first subarray? That is XOR value is 1. For this combination, the XOR value of the second subarray, it is actually 2 XOR 3. It is actually 1, 0, 1, 1. The XOR value will be 1, it will be 0. So ultimately 1. So the XOR value is 1. So for this combination and for the first subarray, the XOR value is 1 XOR 2. That means 0, 1 and 1, 0. The XOR value will be this is 1, this is 1, ultimately 3. And the second subarray, the XOR value is 3 because only one element is present. Now, for this the second combination, for this combination, I mean, so what is the maximum subarray, maximum XOR value of the subarray? That is actually 3. Okay. And for this combination, first combination, the maximum XOR value is 1. All are actually 1. So that's why the maximum value is 1. So out of this combination, what is the minimum XOR value? 1. So I have to return this in this combination. If I actually divide this, the partition, if I do the partition in this way, in this combination, I will get the minimum XOR value. Correct? Clear? So that's why here actually the output is 1. Now, so how actually divide this the input array into k number of partition? So let's see the generalized case. For this example, suppose our input array is A, B, C, D, E and our k is equal to 3. Okay, so I is equal to 0. What actually I can do? In the first subarray, I can actually take only one element, that actually only A, and for the next string will be what? This B, C, D, E, and the next starting index will be 1. Correct? So in this actually I can continue exploration. I can actually explore the remaining subarray also. That means for the first subarray I can again take only one element, that is B, and the remaining subarray will be C, D, E, and I will be that time 2. Correct? So in this actually I can continue in this way. Similar way, in the first subarray I can take two elements. One is A, another is B. So A, B. Then for the next possible subarray, the starting index will be I is equal to 2. So that means it will start from C. So again I can take one element. Again I can take two elements in the first subarray. Then the remaining subarray will be E. In this I can actually continue. First explore this, that I will take one element in the next subarray, then the remaining element I will continue. So in this actually I can continue. Now what is your target? Target is to I have to divide exactly k subarray. Correct? I have to generate exactly k subarray. So that means suppose if I take actually each subarray I will take only one element. So if in the first subarray it will be present only A, next subarray it will contain only B, then C, then D, then E. So in this actually it actually generate 5 partition, 5 subarray. This is actually valid for this combination k is equal to 3. No, this is not a valid partition. Correct? So what will be our target? Target is that generate exactly k subarray. Correct? exactly k sub-array. So if it is not valid, then we have to return infinity, because it will be not be counted, because we have to take the minimum value. So if I return the positive in plus infinity, that means it will not be counted. Now else what actually I have to do? Our in recursive actually I am thinking. So current index is I, and j can go from I to n minus 1. So for this, in this example, what actually I am here A B C D E, A B C D E. Suppose I is equal to 0. So here actually I will be 0. So j can go up to 0 to n minus 1. Here actually n is equal to 5. So it can go up to 0 to 4. That means in the first area, first subarray, what actually I can take? So I can take A, then AB, then ABC, ABCD, ABCDE. So you can just see here that here I is equal to 0, J is equal to 0. Here I is equal to 0, J is equal to 1. Here I is equal to 0, J is equal to 2. Here I is equal to 0, J is equal to 3. Here I is equal to 0, J is equal to 4. J indicate the last index of the current subarray. So here actually I is equal to 0, that means you can just see here actually 0, 1, 2, 3, 4. So for A, 0 and 0, only one element is for AB. Starting index is 0, that means I, the starting index of the subarray, current subarray, and the ending index is 1. Correct? J is equal to 1. Clear? In this I can actually continue. So J can go up to 0 to 4, means 0 to n minus 1. So ultimately, if I actually explain this in a general way, so J value can go up to from I to n minus 1. Correct? I can generate this subarray. Now suppose I have generated this subarray A. Then this is one partition. One partition means one subarray I am able to generate this A. For the next remaining subarray is B, C, D, E. So suppose our K is equal to 3. So I have already generated one subarray. So from this remaining subarray, I have to generate what? Remaining two partition, two subarrays. Yeah. So that's why I will, for the recursively, I will try to generate from this remaining number, from this remaining subarrays, from the remaining number of elements, I will try to generate K minus one number of subarrays. Clear? So it will actually return that if I take this subarray and from this remaining subarray, if I try to generate two subarray, what is the minimum XOR? If I return this minimum XOR subarray, if I generate two subarray from this string or subarray or the array, then what is the minimum XOR actually I will get? I can generate. That means what you are trying to say that. So I already have A, and from the remaining subarray B, C, D, E, I want to generate, suppose K is equal to 2. I want to generate two partition or two subarrays. So what actually I can do? I will generate B, and the remaining will be C, D, E. Another will be B, C, another will be D, E. Another will be B, C, D, another will be E. Is it possible to take all the elements in the subarray? No, because I have to generate two partitions. If I actually do that, B, C, D, E, that is not a valid, because I am able to generate only one partition. That is not possible. So this and these three actually are valid. So for this partition, suppose I will get minimum XOR value is B. For this I will get suppose X. So ultimately I have to take only the minimum of this, because it may possible this in this combination I will get the minimum value, minimum XOR. Then actually I will try to divide this, I will try to partition this array in this combination only. Okay, so ultimately I will get the minimum XOR value I can actually get. Minimum XOR of subarray I can generate. Correct? I can generate from the remaining array of k number of partitions. Clear? So now I will check that if I actually take this subarray, this is one possible part, subarray, and from this subarray I will get suppose XOR actually x1. Suppose I got minimum XOR value is x1. Then what will be actually our total XOR value of this combination? In this way actually if I divide this, so I'll get from A and this actually x1. So I have to take the maximum of XOR, maximum of all of this. Then ultimately I have to store the minimum of all of that. Why? Because I have to store I want to return this. What is the minimum XOR value? So I have now calculated for A, and from B, C, D, E, what is the minimum XOR value? What is the maximum XOR value? I know that. Maximum of suppose x1 and x2. I know that. Now ultimately what I have to return? I have to return that what is the minimum XOR value I can actually generate. So that's why again I will try to generate A, B. Then the remaining subarray will be C, D, E. Again, this is one possible way to divide this. So that's why I will actually compare this. That suppose this is the maximum value of A, B, and this actually C, D, E. So this is one possible XOR value, because ultimately what you are trying to do, I have to take the, if I actually generate partition the subarray in if I do the K partition, then the maximum XOR of that one combination will be the XOR value of that partition. Correct. Now for the next partition, in the next combination, I have to generate the maximum XOR value of this for this current combination. So for this combination, I know that the maximum XOR value of will be maximum of AB and CDE. Okay. Next, I will try to generate for ABC one partition and for DE for another partition. So I'll suppose this is x1, x2. So I have to take this max of x1 and x2, because x1 and x2 both together can actually generate a valid combination to partition this input string or input array into K partition. Correct. So that's why ultimately after checking all the partition, all the combination, I have to return the minimum of all of this. So minimum of suppose max of x1, x2, max of x3, x4, in this way. Correct. Because ultimately I have to choose the minimum. But this maximum, actually, because this x1 and x2 are two partition, these two partition actually generating one valid partition. Correct. So that's why this is one current subarray, and this actually the if I take this subarray, so what is the minimum XOR actually I can generate from this remaining subarray? Got it? So this actually suppose x2. So this is the current XOR value of the current subarray, and this is the minimum XOR value I can generate in the remaining subarray, from the remaining subarray. So that's why I have to compare with x1 and x2. Clear? Actually I have to compare x1 and x2, and I will try to generate all the possible subarray from each position. Correct. Now what is the code? It will be more easy to understand now. So, and one more thing before going to the code. So I need to know that properties of XOR. That means A XOR A, it will be 0. Correct. So that means if somehow I already store from 0 to I, what is the XOR value? If I store that, suppose is ith index, I know that from 0 to I know the XOR value. Now suppose I know that from this J, I also know that from 0 to J, what is the XOR value? I know that. Correct. Then I can easily calculate that what is the XOR value for this area from 0 to J to I. How? So total, suppose this is a total XOR xt, suppose, and this is suppose xj, and this is actually xi. So that means xi is equal to xt. Both are clear. 0 to I, it is actually that indicating the total XOR value from 0 to I. Okay. Now I want to calculate this j to I. So that means sj XOR j to I, it will be xt total. Clear? So I want to calculate actually this value. What is the value for this j to I? and I know that if I actually XOR this with this area, then I will get the total XOR value. So this xj is equal to xi. So that means if I do the both the side, if I do XOR of xj, that means xj XOR x of ji XOR xj, it actually xi into XOR of xj. That means it will actually return 0. So x of ji value will be xi XOR xj. Got it? So total XOR value, that is xi. If I do the XOR value of the previous subarray XOR value xj, I will easily identify the XOR value of this area. Clear? This properties. So I will calculate and store that. So from 0 to I means 0 to n minus 1 store that. So prefix of XOR value of index 0, it will be 0, whatever the value is present in the nums of 0, because there is no previous element. And from I is equal to 1 till I less than n, what will be the XOR value from 0 to I? So previously XOR value will be I minus 1. This vector I have already stored that. And the current value nums of I, and I'll take the XOR value and I'll store in the index I. Got it? So after this for loop, I can easily say that from 0 to 0, 0 to 1, 0 to 0 to 0, 0 to 1, 0 to 2, 0 to 3, I can already know that we already know that what is actually the XOR value for each index 0 to I. Correct? This will help me in the future. So now I'm calling this helper function. What actually I am passing? I want to know that from this index 0, I actually till now I have generated only 0 number of partition, and our target is this actual input length. I want to generate k number of subarray. Correct? So that means this is the starting index. From this starting index, I want the previous number of partition I have already generated, and this is the length of input array, and this k is the target number of partition we want to generate. Correct? So that means if our start is equal to n, that means we have reached the input array, end of the input array. So there is any possibility to generate any new subarray? Not possible. So that's why we have to check that if this, suppose this actually j is equal to if k, then this actually valid, return 0. 0 means this is a valid combination. I can actually generate k number of partition in this combination. Else, if it is not equal to k, that means return infinity. Why? Because this is not a valid partition. So if I return infinity, that means this path will not be counted, because I have to take the minimum value. If I return minus infinity, then this path will be calculated, right? Counted as a valid path. But if I return plus infinity, so this will not be counted in the valid, with the valid path. Correct? So that's why if start is equal to n, our condition is to check that have I reached, am I able to reach generate k number of partition or not. If it is possible, then you return 0. Else it is plus infinity. I have already explained why plus infinity. Now, if somehow we already generated k number of partition, so that is not valid, because we have to take all the elements of the input array. It is not possible that suppose a, b, c, d, e, and k is equal to 3. So we will take only a, b, c. So this is a 3. Here actually you can actually say that here to 3 valid sub actually I can generate, but we have to take all the elements. D also should be present in any one of the subarray. So that's why this is not a valid subarray. So that's why if you already reach here, actually this is not fail, this actually not false. Now here actually in this line we are coming, that means we actually have still some element in the input array, but we have already generated k number of subarrays. So that's not a valid element. So again we have to return plus infinity. Correct? Why plus infinity? I have already explained. This is not a valid combination, that's why. Else what I have to do? We will try to explore all the subarrays. That means suppose we actually have a, b, c, d. So first of all I will take a in as a current subarray, and I will check that for this bcd from this bcd I want to generate this j plus 1 number of means I've already generated j plus 1 number of sub-arrays. So if I want to generate this j plus 1 number of sub-arrays from this BCD, so what is the minimum XOR I will get? Minimum XOR I will get, yes. So I will compare this with, because this is together will generate a valid combination. So A and suppose this is actually min XOR. So I have to take this, and ultimately this I have to compare with whole array. So that's why I have to take another variable that actually store plus infinity. I have to compare with this minimum of answer, and this suppose I will got here x. Got it? Why actually I am comparing with answer and with the max, and here we are taking min, because ultimately we have to return the minimum XOR, because ultimately our goal is to minimize the XOR value. Now here actually why actually taking the max, because this is actually one possible valid combination or valid partition I can actually do. So if I do this partition, so this is actually one subarray and this is actually another remaining subarray. So from this subarray actually I know that this is the minimum XOR I can generate. From this actually this is supposed to n. So this a and x will together actually generate a valid partition, correct? K number of partition. So that's why I have to take the maximum of all the subarrays. So here actually one subarray is a. So that's why this will be should be counted with the this x value, what actually getting from the remaining subarray. Got it? And ultimately why actually returning the comparing with minimum global variable answer, because ultimately we are trying to do the minimum XOR for the previous partition. So that's that time I have to return the minimum XOR I can actually generate, right? From here actually we are getting that value. So now go to the code again. So I am calling this helper function, starting index is 0, and the number of partitions I have done here actually till now 0, and n is the input length of the input array, k is the number target, k number of partition we want to do. Now this helper function I will check that if I reach the end of the input array, that means there is no option to generate new subarray. So I will check that am I able to generate k number of partitions. So j is equal to k, that means this is true, so I will return 0. Else if it is not equal to k, return plus infinity int max. Correct? I have already explained why actually returning this value. Similar way I will check that have I already generated k number of subarray. That is not it is not possible, this is not a valid combination. So that time return plus infinity again, j is equal to k. I will come this if condition later. So again I will take another variable answer that actually return the ultimate minimum XOR value I can generate for this starting index with j number of partitions. Okay, so I have already explained that this ending index or the I can generate a new subarray in the from the starting index I to x. It will be from 0 I to less than n. That means here actually a b c d, suppose this is I, so I can generate a, then a b, a b c, a b c d, right? I would explain that. So that's why x can go from 0 to means I to n minus 1 and x plus plus. So current XOR value will be what? If it is I is equal to 0, that means there is no previous subarray. So what will be the XOR value? Current XOR value, whatever actually the XOR value is present in the index x. Else what will happen? Current subarray. So suppose this is actually the index, this is starting index I. So I want to know the XOR value for this subarray. So this is suppose x. So it will be pre of x, XOR value of this I minus 1, this is actually I minus 1. So pre of I minus 1. Got it? So easily I will identify this the XOR value for this subarray only. So that's a prefix pre-XOR value of XOR value of index x and XOR value of I minus 1, because I is the starting index. So the ending index of the previous subarray will be index I minus 1. So that's why I am doing the XOR with the I minus 1 index. Got it? And for the next XOR value, the minimum XOR I can generate from this remaining subarray, I will calling this helper function again recursively, passing the x plus 1, because the next starting index will be x plus 1. And the next number of partition actually I have done j plus 1, because this is actually one partition, one subarray. So that's why it will be increased by 1, j plus 1. and n and k both are actually same. Now this will be a valid combination if I get some valid value from the next XOR from the remaining sub-array. So that's why if next XOR not equal to int max means this is not a valid combination, right? So if it is not int max, that means we actually have some valid combination in the right side of that. So that time it will be this together will be a valid, the current XOR and next XOR will be together will be generated valid combination. So that's why I will take the maximum of current XOR and the next XOR. Okay, and I ultimately are taking the minimum value because this is the minimum of globally of the input string of the input array, minimum XOR value. But ultimately return the minimum XOR value. I can do that. So what we are doing ultimately, we are exploring all the possible partition. So A, then remaining B, C, D, then A, B, then I will explore the B, C, D, then A, B, C, then explore D, then A, B, C, D, then actually in this 4 partition I will take the minimum of on which combination I will get the minimum XOR value. Ultimately we have written that. So that's why for all this combination I will take the maximum. Here also I will take the maximum. Here also I will take the maximum. But when I am comparing these two sub-array, I will take the what is the minimum value, correct? Minimum XOR value. Got it? Now for this approach, this recursive approach, I can actually use the memoized here. How? Memoization actually, how actually we do the memoization in recursive function. So I will check the first the argument of the input, the recursive function. This is I, j, n and k. So what actually argument is changing here? Is I changing? Yes, I actually changing with x plus 1, something like. So what is the range of I? It can start from 0 and it can go up to n, means n minus 1. So range of I is 0 to n minus 1. And j, is j changing? Yes, j is also changing because j is equal to now j plus 1. Clear? So what is the range of j? Range of j is, it will start from 0. Here you can see that we are passing starting with 0 and it can go up to what? It can go up to k, correct? If it is already crossing k, then I return from here. So that's why it can go up to 0 to k minus 1, correct? Is n is changing? No. This is, you can see only one place you are calling this helper function, recursive function, and we are passing the same value n, whatever the input value try. Similar for k also. So here the two things are changing, I and j, and I already identified that what is the range of the I and j. For I, the range is 0 to n minus 1, and for the j, the range is 0 to k minus 1. So I'll take 2D vector of same size. The first row will be from 0 to n minus 1. The next dimension will be 0 to k minus 1. So you can see here that dp, I have taken a dp vector, 2D vector. The first dimension is for n, 0 to n minus 1, and the next dimension will be from 0 to n minus k minus 1. I already explained why. And now I have initialized with minus 1 to easily identify that have I seen this state or not. Okay, if it is not minus 1, that means I have already seen that. Okay, so that's why here actually before calculating the value, I am checking that, I will check that is it minus 1 not. If it is minus 1 not equal to minus 1, that means I have already checked that state in the same state. I is actually also same, j also same, and n and k are both actually same. So if it is not equal to minus 1, I return the whatever value I have in this position. Else I will continue to calculate all the values, explore all the partition, then ultimately we will explore the store the minimum of all of that combination. And I, before returning directly the value, minimum XOR value, I will store that in the position of I comma j, because this is the input value I comma j, and return that. After that you will return that. Got it? So if you have any suggestion, any comment, you will comment on that. And if you found this video useful, please like the video and also subscribe the channel. Thank you. Bye.